All right, let's get right into it. For the longest time, if you were a company, you built your own data centers, massive, expensive buildings full of servers. But over the last decade or so, we've seen this incredible shift. So the real question is why? Why is seemingly everyone moving away from their own hardware and into the public cloud? Let's figure it out.
Well, it really started with this exact problem. The old way of doing things where you controlled every single piece of hardware, it it accidentally created a monster. As businesses grew, trying to manage all of that physical infrastructure just became this unbelievably complex, slow, and expensive nightmare. They were trying to wrestle a behemoth. And this right here, this was the core conflict, the source of all the friction. On one side, you have your developers, the people trying to build and innovate, who need servers like right now at the click of a button. But on the other side, you had the reality of IT, which was a 4 to 8 week waiting period just to get the physical servers delivered. That gap was absolutely crushing innovation. So obviously, something had to give. And it did, in a huge way. The public cloud came along not just as a new piece of tech, but as a fundamentally new way to think about building the digital world. First off, you get this incredible flexibility. I mean, imagine you just spent millions on thousands of servers, and then a year later, some revolutionary new chip comes out that makes yours obsolete. Well, tough luck, you're stuck. The cloud just gets rid of those physical handcuffs. It lets you use the latest and greatest tech the very moment it becomes available. And then there's scalability. Let's say you want to launch your service around the world. In the old days, that was a multi-year project. You're talking about building data centers, shipping hardware, dealing with logistics. It was a massive undertaking. With the cloud, you can have a global presence in minutes. That's not just an improvement, it's a total game changer. Okay, what about reliability? Think about your banking app. It has to work all the time. Downtime is just not an option. So reliability is just a measure of how often a service is up and running. And believe me, in the cloud, the standards for this are unbelievably high. You often hear about the gold standard, this number right here. 5 nines, 99.999%. It looks impressive on paper, sure, but what does that actually feel like in the real world? What does it mean for you?
It means this: less than 6 minutes of downtime in a whole year. For most companies, achieving that level of reliability on their own is practically impossible. But for the major cloud providers, Amazon, Google, Microsoft, that's the bar. It's an incredible promise. Now let's talk about elasticity, which is all about efficiency. Instead of buying a mountain of servers just to handle your busiest day of the year, like Black Friday, and then letting them collect dust for the other 364 days, elasticity means your system automatically scales up when you're busy and scales right back down when you're not. You only pay for exactly what you use when you use it. No more waste. And when you put all of this together, what you get is agility. You've removed the roadblocks. Your developers can spin up new environments, test a crazy idea, and launch code in the blink of an eye. It's a direct line from an idea to a product, and that speed is how you win. And of course, we have to talk about the big one: cost. The cloud completely rewrites the rules of tech economics. You're not cutting a multi-million-dollar check up front for a building full of hardware anymore. Instead, technology becomes a utility, just like electricity. You turn it on, you use what you need, and you pay the bill at the end of the month. You know, this shift in how we pay for things is so profound, it's worth taking a closer look. Moving to the cloud isn't just a choice for engineers, it's a financial revolution that has totally changed the way companies think about their budgets. So, the old world ran on what's called capital expenditure, or CapEx. This is all about big upfront investments. You're buying physical things, buildings, servers, networking gear, and you own them. It's a massive cash outlay before you even get started. The cloud flips that whole model on its head. It turns IT spending into an operating expenditure, or OPEX. So instead of a giant one-time purchase, it's just an ongoing recurring cost for a service you're using. Again, think of it just like your power bill. And putting them side by side like this makes the difference so clear. You're going from making huge upfront payments to just paying as you go, from owning a physical asset that gets old to just using a service that's always up to date, from rigid multi-year plans to being able to scale up or down whenever you need to. That financial flexibility is just as powerful as the technical kind. Okay, so this all sounds amazing, but of course, it's not like every company on Earth can just flip a switch and move to the public cloud overnight. It's a bit more nuanced than that, which is why a few different models have popped up. So on one hand, you have a private cloud. This is something you build and own yourself. It gives you maximum control, which is great for some really specific, strict regulations. But you're limited by the hardware you own, and you don't get new tech as fast. On the other hand, the public cloud gives you almost infinite scale and all the latest services, but you're sharing the underlying infrastructure with others.
And that's why, for a lot of big companies that already have a huge investment in their own data centers, the answer is a hybrid cloud. They basically connect their private world to the public cloud, letting them get the best of both. They can keep sensitive data in-house while using the public cloud's scale and innovation for other things. Now, to make all this a little less abstract, let's zoom in on a real-world example. Because not all clouds are created equal, and one of the most interesting differentiators is the network itself. So let's take a look at what makes Google's approach so unique. So, here's the question. When your data is zipping around the planet, the network it travels on is absolutely critical. So what did Google do that was so different, so special? The answer, well, it's pretty simple to say, but it's also just mind-bogglingly ambitious. Instead of relying on the regular public internet, which is kind of a chaotic patchwork of different networks, Google just built its own, a private, super-fast, global internet just for their customers. I mean, look at this. It literally starts at the bottom of the ocean. Google laid its own private fiber optic cables under the sea to connect continents. So when your data goes from, say, New York to London on their cloud, it's not hopping across the public internet. It's riding on Google's own private underwater highway. And all of those undersea cables, they're the threads that stitch together this entire global web of Google's data centers. What this does is it creates a single, unified network across the whole planet. It means your servers in Asia can talk to your servers in South America as if they were in the same room, securely and instantly. And that really brings us to the final question, and it's a question for you. This whole migration to the cloud has put the power of planet-scale infrastructure into the hands of anyone with an idea. The old physical limits are just gone. So when building something global is as easy as writing a single line of code, what problem are you going to solve?